All right, welcome everyone. If you are a junior dev, you absolutely know that incredible rush when your code finally compiles, the tests actually pass, and boom, the app does exactly what it's supposed to do. Getting your code to just work is a huge milestone. Be proud of that. But here is the secret sauce that separates beginners from seasoned engineers. Writing functional code? That's really just step one. Because as your projects grow, that code can quickly morph into a messy, tangled nightmare that is virtually impossible to maintain. And that is exactly why I put together this explainer. Consider this your hands-on tutorial, your survival guide, really, for the essential techniques you need to transform purely working code into clean, professional, and maintainable software. Think of me as your mentor today, and here is our syllabus. First, what actually is code refactoring? Then we'll open up the core refactoring toolkit. After that, simplifying complex logic. Next, essential guardrails and common mistakes. And finally, we'll tie it all together with a real-world refactoring example.
Section 1. What is code refactoring? Okay, let's dive right into this foundational question.
So, code refactoring is the formal process of restructuring your existing code to make it cleaner, more readable, more efficient, and easier to maintain. But notice that critical, absolutely crucial piece at the very end of the definition, without changing external behavior. Look, when you refactor, you are not adding shiny new features. You're not squashing user-facing bugs. You are entirely focused on improving the internal structure of the code while making absolutely sure the output remains exactly the same. To make this super clear, think of it like renovating a house. When you remodel, you aren't tearing down the building to turn it into a grocery store, right? The house still serves the exact same purpose. It's still a place to live. But inside, maybe you knock down a wall to open up the living room, you organize those messy kitchen cabinets, and you finally update that rusty plumbing. The house functions exactly as it did before, but it is now vastly more organized, attractive, and just way easier to live in. Well, that's exactly what we're doing to our code.
Section 2. The core refactoring toolkit. Now that we've got the philosophy down, let's head into the trenches and look at side-by-side comparisons of the absolute highest yield habits you can start using today. The first and honestly most immediate improvement you can make is renaming your variables. Take a look at the bad code. You might write let d equals 86,400. Now when you're writing it, sure, you know D stands for days. But what happens when a teammate, or honestly even you, 6 months from now, reads it? It's completely ambiguous. Now look at the refactored version. If you just change that to let seconds in day equals 86,400, the code instantly becomes self-explanatory. You don't need a massive clunky block of comments to explain what the data is. The variable name itself tells the story. Remember, clean code is read way more often than it's written, so optimizing for readability is paramount. Next up in our toolkit is extracting functions. A classic trap is the single massive function, let's call it process order, that tries to validate the cart, charge the credit card, and send an email receipt all at once. This makes your code super rigid and incredibly difficult to test. The fix? Break that giant function down. Extract its responsibilities into smaller isolated functions, like validate cart, charge card, and send receipt. Not only does this kill duplicate code, because you can now call those smaller functions from anywhere, but it makes your modules highly reusable and much, much easier to write isolated tests for. Section 3. Simplifying complex logic. Moving right along, let's specifically target the confusing, deeply nested logic that makes debugging just an absolute nightmare. And this brilliantly illustrates one of my all-time favorite techniques, using early returns, or what some folks call guard clauses. In the bad code, you've got these deeply nested if-else statements that look like a giant arrowhead pointing to the right. If user exists, then if user has permissions, then if account is active. Man, tracing that logic requires serious mental gymnastics. But in the refactored version, we simplify it. If user is null, return. You just exit immediately. This flattens the logic, strips out all those annoying nest of brackets, and creates a streamlined top-to-bottom flow that is incredibly easy to read. Now, I want to ask you a question directly. Have you ever been reading through a file, stumbled across a random line of math, and you just stop and think, wait, what in the world does 0.18 mean? We call this a magic number. It's an unexplained value hard-coded straight into the logic, scattered all over a file, causing utter confusion for literally anyone who didn't write it. To fix this, we've got a very clear, highly actionable checklist. Step 1, identify those unexplained magic numbers hiding in your code. Step 2, create a named constant that explicitly describes what that number actually represents. And step 3,
Replace every single hard-coded instance of that number with your shiny new named constant. Let's actually see that in action. In the bad code, we're multiplying some total by 0.18. It's a total mystery, right? But in the refactored version, by following our checklist, we multiply by a named constant called tax rate, which we've clearly defined as 0.18 at the top. Boom! Instantly, the clarity issues are resolved. The math suddenly makes logical sense to human eyes. And bonus, if the tax rate ever changes, you only have to update it in one single place. Section 4, Guardrails and Common Mistakes. Okay, we've covered some seriously powerful transformation techniques, but I need to shift the tone to a cautionary one for just a second. Because while refactoring is an incredible tool, it is also incredibly easy to break things if you aren't careful. So let's look at the guardrails. This right here is the absolute golden rule of this entire explainer. I literally cannot stress this enough. Refactoring improves structure, not behavior. Do not change external functionality. Look, I know it can be super tempting when you're cleaning up a function to say, oh, I'll just add this one little feature while I'm in here. Do not do it. Refactoring and feature building are two totally separate workflows. If you mix them, you are going to introduce bugs that are nearly impossible to track down. To enforce that golden rule, you must operate within a frequent testing loop. You need to refactor in small, deliberate steps. Change a variable name? Run your tests. Extract a function? Run your tests. This ensures that at every single microstep, the functionality remains unchanged. Plus, you absolutely must lean heavily on version control, like Git. If a test fails after a tiny change, version control lets you instantly revert back to a working state. It's your ultimate safety net. When developers ignore these guardrails, they fall into some very common, very predictable traps. Refactoring without tests, that means you're flying blind. You have literally no way of knowing if you accidentally introduced a bug. Another massive mistake is trying to refactor the whole code base all at once. Making sweeping changes across a dozen files increases your risk exponentially. And finally, skipping code reviews. Peer reviews are essential, guys, because a fresh set of eyes will almost always catch potential issues or suggest better structural improvements that you just missed. Section 5, Real-World Refactoring Example. All right, we have our techniques, we have our guardrails in place. Let's bring all of this together for the climax of our walkthrough and look at a real-world scenario. Let's move to the code and see how this builds into a final masterpiece. In the original version, we have this messy, real-world block crammed into one massive function, complete with deeply nested logic and unexplained 3.14s everywhere. I mean, sure, it works, but it's incredibly fragile. Now, look at the refactored version. We've applied our entire toolkit. We extracted the responsibilities into smaller functions, we used early returns to flatten out that logic, we renamed variables to actually be descriptive, and we swapped that random 3.14 for a named constant called pi. The functionality of both sides? Perfectly identical. But the result of our refactored code is absolutely profound. It is vastly more readable for the team. Because it's broken into modular pieces, it's much easier to maintain and update. When things inevitably go wrong, it is infinitely easier to debug. And when the time comes to add new features later on, this clean foundation makes the whole code base so much easier to extend. I want to leave you with a really great philosophical takeaway from our source material today. Good programmers write code that works. Great programmers write code that is easy to understand, maintain, and improve. Never forget that, as a software engineer, you are writing code for human readers just as much, if not more, than you are writing it for machines. Refactoring is the bridge that takes you from being a good programmer to a great one. So, as we wrap up this explainer, I want to leave you with a provocative question to reflect on regarding your current projects. If another developer took over your project today, right this very second, what would they think of your code? Would they be able to read it like a well-organized book, or would they be totally lost in a maze of magic numbers and nested logic? Take these refactoring techniques, apply them safely, and go build code you can be truly proud of. Thanks so much for joining me, and
if you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to Future Break Coder, because many exciting coding and futuristic tech videos are coming soon.